Welcome to another video in my channel. In this video, I will be discussing two laws of logarithm. One is the product law of logarithm, and then the other one is the power law or law of power of logarithm. But before I proceed, we need to know what logarithm is about. The logarithm of a number is the exponent or power or index by which another number called the base is raised to produce that number. When we say logarithm, we can think of the inverse of exponents. For example, if we have a number like 8, we know that 2 raised to power 3 is 8. So the exponent by which 2 is raised to get 8 is 3. Now, we can rewrite it as logarithm. That's like saying log to base 2 of 8 is 3. So it is useful to think of logarithm as the inverse of an exponential. Another example is this. We can have log to base x of x raised to power y giving us y. We can also rewrite this expression as x raised to power log to base x of y. It will still give us y. So when we think of exponential or exponent and logarithm, they are inverse operations. Let's first of all look at the product law of logarithm. The product law of logarithm has it that log to base a of x plus log to base a of y is equal to log to base a of x times y. So the logarithm of a product is the sum of logarithms of the factors. This is a product. So when we split them into different logarithms, so long as they have the same base, we are going to sum up the factors to get the same thing. An example is this. If we have log to base 3 of 5 plus log to base 3 of 7, we will have log to base 3 of 5 times 7, and 5 times 7 is 35. That is log to base 3 of 35. So when we add log to base 3 of 5 to log to base 3 of 7, we will get log to base 3 of 35. That is what the product law says. Now we can prove this law. Let's imagine, or let's assume that log to base a of x is m and log to base a of y is, for example, n. Now, if we convert this to indices, that is, if we turn this logarithm to indices the way we did here, we'll have a raised to power m is equal to x and a raised to power n is equal to y. Now, we are dealing with product. That means we are going to multiply x and y together. So x times y will give us a raised to power m times a raised to power n. And in indices, if we have the same base and they have different powers, we are going to add the powers together when we are multiplying them. So a raised to power m plus n becomes the result of this. Now, so x times y will give us x times y will give us a raised to power m plus n. Now let us take log of both sides. If we take log of both sides, that is log to base a of both sides, we have log to base a of x times y will give us log to base a of a bracket m plus n. It is important to put this bracket here because we are considering m and n as a single term. Now, this power m plus n will come down, giving us m plus n. Let's still put them in bracket, log to base a of a. Now, log to base a of x times y will now give us m plus n log to base a of a. Log to base a of a is 1. So this value here is 1. So we'll have m plus n is log to base a of x plus x times y rather. Now, let's remember that m is log to base a of x. So we'll write it log to base a of x. And also n is log to base a of y, log to base a of y. So we have log to base a of x times y. The next one is the power law. Now, if I have log to base a of x raised to power p, it is equal to p log to base a of x. I can prove this law using addition law. Now, let us first of all give an example. Assuming we have log to base a of x raised to power 2, we know it is the same thing as log to base a of x times x. Now, using addition law, we can separate this part of the equation. It becomes log to base a of x plus log to base a of x, which is our log to base a of x raised to power 2. When we add these two together, we have 2 log to base a of x, which is our log to base a of x raised to power 2. So generally, log to base a of x raised to power p is p log to base a of x.